Hello friends, today we discuss about the memory element latch and flip-flop. We read about the working principle, types and operation and application. Question is, what is a memory element? The memory element is a digital circuit that stores binary information 0 or 1, essential component of sequential circuit, retain data until it is changed. For basic operation of memory, we need for data storage, state retention, counting, timing and control system. This is the simple block diagram in which we can see about the memory element. Here data in means input and data out means output, but it is a feedback path. If we explain it, data in means input 0 or 1 is applied to the memory element, control input, clock or enable signal. It is very important. Clock or enable signal decide when the data will be stored or updated. Data out means stored data available at the output. Then feedback path. In simple word, a memory element acts like a digital storage cell that remember one bit of information 0 or 1 and hold it until told to change. Now question is, how memory stores data? Memory uses a positive feedback to store information. It has two stable states. The stable state is logic 0 and logic 1. These are the two stable states. Means if we can use cross coupled inverter connection. This is a bistable circuit. This is one input, this is another input. Similarly, it is one output and other output. If it is in 0, this is 1. Similarly, if it is 1, the other is 0. Then we go for the feedback loop. The output is returned to the input of the other inverter. Any change at one output affects the other inverter, which try to oppose that change and brings the circuit back to its original state. This is called positive feedback. Now we go for the stable state. The circuit settles in one of its two possible states. Logic 1, Q equal to 0, Q bar equal to 1, or logic 0 state, Q equal to 0, Q bar equal to 1. State transition. The change of the state, an external input must momentarily force the circuit to the opposite condition. When Q equal to 0, Q bar equal to 1. When Q equal to 1, Q bar equal to 0 and apply input to make this. Now one question comes to our mind, that what is combinational circuit and what is sequential logic circuit. If we see the diagram, this is the block diagram of combinational circuit and this is the diagram of sequential circuit. Here memory element is added in the combinational circuit to form a sequential circuit. Here is the basic difference written in the combinational and sequential circuit. Memory In case of combinational circuit there is no memory, and for sequential circuit it has memory. Similarly, for output dependence, output depends on present input, output depends on present input and previous state. Now these are the some parameter which you found the difference between combinational and sequential circuit. Example of some differential and sequential logic circuit are: first is adder, multiplexer, decoder, logic gates. Similarly, if we go for the sequential if we go for the example of sequential circuit, we found flip-flop, counter, shift register, and this type of state machine. Now we go for the basic block of the memory element, that is latch. The definition of latch is: a latch is the level triggered memory element. Another important thing is trigger. Sequential circuit is a triggering circuit. Triggering means as much as there is no clock is comes, it not triggering. Output changes whenever enable is active. Similarly, these are the characteristics, and application is temporary storage and register. If you see that it is a SR latch using NOR gate, and this is the truth table. Similarly, this is the excitation table, and this is for NAND gate. This is the truth table and this is the excitation table. In case of truth table, we can see that when S and R are both are 0, there no change, means hold state. Similarly, if we apply 1 to S and 0 to R, then it is in set condition. Similarly, when we apply 0 to S and 1 to R, it is reset condition. If we apply both 1 and 1 to the S and R, then it is in invalid condition. This is all about SR latch. Here another thing is asynchronous counter versus synchronous counter. Asynchronous means one clock is present and other are operated through the output of the previous clock. But in case of synchronous counter, we can see that every block has single clock diagram. Key difference is flip-flop are triggered sequentially and flip-flop are triggered simultaneously. If we see that this is the SR latch using NOR gate. Now this is the step-by-step working, and this is the timing diagram in which the SR latch works, and this is the working and operation which we can see in the previous. Now if we see that SR latch using NAND gate, this is active low logic, and this is the block diagram and truth table. Similarly, this is the working of the NAND based SR latch which we see. Now we go for the clocked based SR latch. Here we can see that using NOR gate means NOR based SR latch is operated by a clock. This is the external clock and these are the two NAND gates. Similarly here, this is the NAND based SR latch and this is the clock signal driven by another two NAND gates, S bar and R bar. And overall this is the timing diagram and truth tables. If we see that this is the working of now we see that the advantages over basic SR latch. These are the applications used in register, counter, data storage, control system and finite state machine. Now we go for the flip-flop. This is edge triggering memory element. Definition is a flip-flop is an edge trigger memory element. It stores one bit of data. The output changes state only on the clock edge. In the previous page, we see that the SR clock based SR latch is level triggering, but here it is edge triggering. This is the basic difference between latch and flip-flop, which we can see the triggering is level trigger, here it is edge trigger, and operation if you see this is asynchronous and this is synchronous. Similarly so on. Now we go for the flip-flop using NOR gates. This is the positive logic and this is the circuit diagram. This is the truth table and working of SR based. Now we go for the types of flip-flop. There are 4 to 5 number of flip-flop is present. First one is SR, then is JK. SR stand for set and reset. First one is SR flip-flop, set, reset. Then another one is JK flip-flop. Then is T flip-flop, D flip-flop. And last one is master slave flip-flop, which is very similar to JK flip-flop. First we go for SR and JK flip-flop. In case of SR flip-flop, this is the basic latch based diagram and the truth table is given here. Similarly for JK, we used another two external NAND gate with a clock signal. And similarly for truth table and operation. Then we go for the D and T flip-flop. This is D. D means data flip-flop and T means toggling flip-flop. This is the block diagram and working. Here we can see this is the master latch and slave latch. And we can see the input is 1. Means if we see that only one input is present D and another one is second input is the NOT operation of D. And this is the timing diagram. If we go for a comparison of latch and flip-flop, we can find out these are the basic parameters which we found. These are some important application of the flip-flop for a register, counter, shift register, RAM means random access memory, CPU, microprocessor, PLC and communication system, state machine. If we go for the summary and conclusion, we found that memory element stores 1 bit information. It uses feedback to retain the state. Then latch is level trigger, Flip-flop is edge trigger. NAND and or NOR gate are used for implementation. Flip-flop are the basic building block of the sequential circuit. Similarly, these are the conclusion which we found at last of the flip-flop. This is the role in digital system, memory element, sequential circuit, digital system and real world application. Thank you.